Now let us move on to the one of most widely used devices in modern entertainment electronics, the digital camera. Today almost everyone uses a digital camera either as a standalone camera or as part of a smartphone. Digital cameras have completely replaced traditional film cameras because they provide instant image viewing, better storage and easy sharing of photographs. According to the slide, a digital camera can be considered as a modification of the conventional analog camera. Most of the components remain the same, but instead of recording images on a photographic film, a digital camera uses an image sensor to capture the image. Let us understand how a digital camera works. Whenever we take a photograph, light from the object first enters the camera through the lens. The lens focuses this light to an image sensor placed inside the camera. Unlike an analog camera where the image is formed on a chemical film, a digital camera converts the incoming light directly into an electrical signal. These electrical signals are processed by an electronic storage image processor inside the camera. The processor adjusts brightness, color, contrast and softness before finally storing the image in digital format on a memory card. One of the biggest advantages of digital cameras is that we can immediately view the captured image on the display screen. If the picture is not satisfactory, we can simply delete it and capture another one without wasting film. This has made photography much easier, faster and more economical. Now let us discuss the most important component inside a digital camera, the image sensor. The image sensor is actually the heart of the digital camera. As mentioned in your slide, the image sensor may be either a charge coupled device, commonly called CCD, or a complementary metal oxide semiconductor known as CMOS. Both sensors perform the same function. They convert light falling on them into electrical charges. The sensor consists of millions of tiny light sensitive elements called pixels. Each pixel measures the intensity of light falling on it. The camera processor collects information from all these pixels and reconstructs the complete digital image. The greater the number of pixels, the higher the image resolution and the finer the image details. The slide also mentions that the image sensor is basically a microchip having a width of approximately 10 millimeters, containing an array of sensing elements. Now let us compare CCD and CMOS sensors. A CCD sensor generally produces excellent image quality with lower image noise and better cloud accuracy or color accuracy. Because of its superior image quality, the CCD technology has traditionally been used in professional and high-end cameras. However, CCD sensors are comparatively expensive and consume more electrical power. On the other hand, CMOS sensors are less expensive to manufacture and consume much less power. Modern CMOS technology has improved significantly, and today most smartphones, webcams, DSLR cameras and mirrorless cameras use advanced CMOS sensors because they provide excellent performance at a lower cost. Therefore, the choice between CCD and CMOS depends on the required image quality, cost and application. Digital cameras are now used in almost every field. They are used for the personal photography, professional photography, journalism, scientific research, satellite imaging, medical diagnosis, industrial inspection, security surveillance, wildlife photography and even space exploration. Because of continuous improvement in sensor technology and image processing, today's digital cameras are capable of producing extremely high resolution images with outstanding color quality. Now let us study some important parameters of digital camera. These parameters determine the quality of image captured by the camera. The first parameter is aperture. According to the slide, the aperture refers to the diameter of the opening in the camera. You can think of the aperture as the pupil of the human eye. In bright sunlight, the pupil becomes smaller to reduce the amount of incoming light. Similarly, in darkness, the pupil becomes larger to allow more light to enter. A camera aperture works in exactly the same manner. A larger aperture allows more light to reach the image sensor. This is useful when taking photographs in dim light conditions. A smaller aperture allows less light, provides greater depth of the field, making distant objects appear sharper. The second parameter is shutter speed. As mentioned in the slide, the shutter speed refers to the rate and amount of light that passes through the aperture. The shutter is like a small door placed in front of the image sensor. It opens for a very short period while taking a photograph. If the shutter remains open for a longer time, more light enters to the camera. If it opens only for a fraction of a second, less light enters. Fast shutter speeds are used to capture moving objects such as racing cars, athletics, or flying birds without blur. Slow shutter speeds are used for night photography and artistic photography where more light is required. The third parameter is focal length. According to this slide, focal length is the distance between the lens and the image sensor determined by the lens design. Focal length determines the field of view. A short focal length provides a wide angle view suitable for landscapes. A long focal length provides a narrow field of view with magnification, making it suitable for wildlife and sports photography. The fourth parameter is lens. The lens is one of the most important parts of any camera. It collects light from the object and focuses it accurately onto the image sensor. The slide mentions different lens types such as fixed focus lenses, optical zoom lenses with automatic focus, digital zoom and replaceable lens systems. Among these, optical zoom provides better image quality because it uses actual lens movement. Digital zoom simply enlarges the image electronically, which may reduce image quality. Professional DSLR and mirrorless cameras allow photographers to replace lenses depending on the application. For example, a macro lens is used for close-up photography, while a telephoto lens is used for photographing distant objects. So that is end of this today's lecture. In the next lecture, we will see about the digital camera figure, image capture process, storage, practical applications, advantages, limitations, and real-life examples before moving to the camcorder sections. So we have to understand in detail about figure and block diagram to know in detail about the working process of a digital camera. So we have already seen the basics of digital camera and the different parts of parameters of digital camera in today's lecture. So I hope today's lecture given you an overview about the digital camera, and we came to know many hidden features and hidden things about digital camera. With this basic information, in the next lecture we will go through in detail about the working of the digital camera with block diagram and camcorders. Thank you.